The x-axis is, again, real axis. Y is the imaginary. So we can write it as x plus yi, because y is the imaginary. X is r cosine theta. Y is r sine theta. And r is the length of this segment. So from rectangular form, which is x plus yi, equals to, what is x? R cosine theta plus I is the imaginary number. Y is what? R sine theta. So you have r in common, so you can take out r. So it's r times, parentheses, cosine theta plus I sine theta. That's a polar form. And sometimes, a lot of times, we just simplify it and just write r cis, cosine, is, cis, and theta. So we can save lots of lead and ink. Okay. R cis theta is exact same thing. No. They're all same thing. Okay, so let's try it. First, graph them. Graph the complex number on the rectangular coordinate plane, then express in polar form. This is x, right? This is y. So what is x? 1. What is y? 1, 2, 3, 4, negative 4. It's very important to get the coordinate right because your theta, the angle, which is the direction from the positive x-axis, change. So make sure you're very be careful with the signs. Just like other conversion from rectangular to polar, it's the exact same thing. They just put it in a complex, different form. Not quite sure why they will do it, but it's a good way of learning, following directions, and plugging in numbers. So what do we need? We need r and theta, right? R is the length. So what do? It's square root of 1 squared plus negative 4 squared, which is same as 4 squared. So I'm going to just write it in positive. So it is square root of 17. Just leave it as it is. Just simplify the radicals. How do you find the theta? The reference angle, which will be this one right here, you can easily find it by what? Arctangent of y over x, which is 4 over 1. So what do? It's arctangent of 4, right? So you get 75.964. So this is 75.964. So is that your theta? No. What's your theta? From here to here, right? So what would you do? 360 minus that. It's on the fourth quadrant. So you get 360 minus that. 284.036. So theta, 284.036 degrees. So now we just put it in polar. So how do you put that? It's r outside, square root of 17, cosine of 284.036 plus I sine of 284.036. Or, do you want me to show you the shorter way? It is what? Square root of 17, what? Cis 281.036 degrees. They're exact same thing. 284. Good point. This? What did I say? So I said I don't really know why they will ask you to do it, but as we get, like tomorrow, it will be much more complicated formulas that we're going to use with complex numbers, so they want you to know if you can follow directions, remember the steps, and plug it in correctly. They don't give you any of these. Tomorrow, yeah, it will be 4 formulas that you have to memorize. So that it will be very helpful in your life. It will use more cells in your brain. So when you study for other subjects, yeah, you can do much better. So thanks to complex numbers. All right, number 2. Graph the complex number on the rectangular coordinate plane, then express it in polar form. So this will be what? -3 is x, and this is your x. This is your y. So this is on the 3rd quadrant. So let's find r. R equals to, just like the length, radius. It's a Pythagorean theorem. It is 3 squared plus 2 squared. I know it's negative, but when you square it becomes positive. So I'd rather put it in positive. So it's square root of 9 plus 4, 13. What about theta? Arctangent. This is the reference angle, right? Y over x, 2 over 3. So when you put that into the calculator, it's going to give you this, but that's not our final answer. We have to find this whole thing, so we're going to add 180 to it, right? So what do you get? It's arctangent of, inverse tangent of 2/3, 33.690. Plus 1? 33.690, comma mistake. You guys just leave it as this theta, but it's on the 3rd quadrant, so you will add it with 180. So 33.690, your theta is what? 213.690 degrees. So now, if you use the shortened term, it will be r square root of 13, what? Cis cosine plus I times sine of theta. Yes.